It's a 1931 AWA Radiola, a TRF set, 5 valves. It's been sitting in my garage for a few months now. I haven't done it yet. I haven't had a look at it yet. I haven't even looked at it. I haven't looked at the back of it. I brought it home and sat it there. So it's got some junk on it. I'll get rid of that. And I might pull it out and see what's inside. There's the front of the cabinet. That's a very attractive radio. It's got a sunburst pattern on the front, which will come back when we restore it. But little dial. There's a couple of switches, I believe. One's phono and one's local distance, tuning, tone. I'm not sure what the other ones are. One's volume, obviously. I'm not sure what the other one is. I've got the knobs for this. I've taken them off to keep them safe. It's missing these little escutcheons here. I think they were brass escutcheons. I don't know what I'm going to do about that. If I can try and manufacture something, I don't know. Sits on these 4 turned legs. They'll clean up nice. Perhaps put a bit of dark in there, Japan black or something inside the flutes. Nice bit of fretwork on the front as well. It's very, very ornate. I don't think the fabric's in good condition, but it's stained. I'm not sure how we're going to fix that. We might be able to do something with that and retain the original. Pretty good inside. Very rusty. It's a nuisance. It's very rusty on the base. There's a loudspeaker. That'll be the phono, and that'll be the phono power supply. Electrodynamic speaker. Wow, still got the tag on it. Still got the quality control tag on it for the speaker. So it says final inspection. The date on it is the 8th of the 5th, 1931. You can see some holes in the speaker cone there. It's a TRF set, so it's got 3 tuning gangs, 1, 2 and 3. So it'll be 3-stage tuning. I believe they're ganged together, so it's only one knob and it all moves hit as one. So we've got some paperwork tacked inside there, patents. Yeah. Well, there it is out of the case. There's the 3 tuning condensers, and there's a metal band driving them all. So turning one turns the other 2. So it still works pretty well. I was expecting those to be broken actually. There's some sort of friction device on that, which is working okay at the moment. We'll probably have to look at that. Look at the size of the rheostat for the potentiometer for the volume. That's crazy. This one is a tone control. The other shaft that I couldn't quite think of what it would be. There's the 2 switches, and I have no idea. What is that? Oh, I don't know what that is. What's that? Is that tone? No, I don't know. No, that can't be tone, can it? Not sure what to do about the rust. I wanted to keep it reasonably original. I'll see how it cleans up. There's a couple of options as far as restoring it. We could paint it, of course, but it does take away its originality though. Get it stripped and re-plated. It'll be CAD plated. I assume we can get some sort of plating put on it. The rust hasn't eaten into it, so it may not be too bad. These can be painted. They've been painted. They were painted originally, so they'll paint up alright, no problem at all. These can be repainted too. Looks like the same colour. So yeah. So there's the 3 tuned circuits with their condensers, or their tuned their air condensers or air capacitors. That's the output valve. It's a 245, and around here is the rectifier, which I believe is an 80. I believe these cans contain capacitors. There must be choke coils in there as well, because there's one there. One's a choke. One will be a choke, and one's an output transformer, I assume. You'll notice they turn 90 degrees to each other, so they don't interfere with each other, even at that distance. It's got timber blocks on the end of the chassis. Big resistor strip there, another one there. It's all very neat inside. It's good. Very good. Well, there's the speaker. It's in very good condition. The light I could see with the joins in the suspension more than, well, there's no holes in the cone as far as I can tell. So don't know how sturdy. It feels pretty good. Wow. Okay. So now I assume these have lost a bit of flexibility. I don't know what you do about that. Anyway, we'll test it out first and see if it's good enough. If I don't have to do anything to it, that'll be terrific. What I will do is make a plate over to put over that, a bit of ply or something to put over the top of that to protect it so I don't put my fingers through it. Yeah, so that's great, terrific. Well, I put the chassis inside and I've put it on this handling frame, so it's a bit easier to flip over on its back and have a look at it. As we looked at yesterday, here's the three RF amplifying valves, their corresponding tuning capacitors. There's some transformers in there for the RF transformers. These two cans, one is going to have a transformer in it, the power transformer. I don't know why they do it in there. That's just 1930 technology, I guess. So the transformer's in there somewhere, and I guess this one's just full of capacitors. The rectifier valve sits up at this end here. So I'm going to flip it over. We'll see what goes into these two cans. As we can see, the rectifier's up this end. There's the three RF amplifying valves, and there's the output valve sitting up here. These resistors won't be original. I have no idea what that is. It may well be a capacitor, I reckon. I think I'd almost bet it's a capacitor. Now I notice this is where the speaker plugs in through here, and that's all broken off there. I'm going to have to fix that. So this being the number 80 rectifier valve, there's the two wires coming out. That'll be the secondaries going to the rectifier. These will be the 5-volt supply. Here, coming out of here. One goes there, one goes there. So that'll be the 5-volt, and there's your rectified AC coming out there. And it goes off to the field coil, I would say. And on the speaker here, it would come back and then go off to where it goes off to. So I don't usually show the circuit diagram too much unless it's something particular, but this radio is so different that I think I need to just go through it quickly. Now I've spent a couple of minutes trying to work out what's going on. It's pretty simple. Power supply is here in this area. There's 1, 2, 3 RF amplifiers, and these are the 3 RF sections here, each with its own little tuning capacitor. Here's the third one, and this is also used as a detector valve, this valve here. So rectified AC goes through the field coil here. It goes straight back to the center tap, so it's effectively across that secondary. A tap off here goes through a set of smoothing caps, some chokes, and one part of it goes off here through the output transformer to the output valve plate. Back here again we go through another choke, another smoothing cap, and then off here, and this goes directly to the plate of the third RF, which is also a detector. From here we're going up, straight up here, we're going to the plates of the first 2 RF valves, amplifiers. So the plate for this valve comes off here, the plate voltage is supplied up this line here. So that'll be a higher voltage than the plates, the other 2 plates. There's another tapping off here through another 5.6k resistor, and that's going to go to the screens. There's the volume control down this end. That's unusual, isn't it? So that supply then is going through to the cathodes on the first 2. Now the volume pot here has got the wiper is going off to the screen of the first 2 RF valves. Okay, so what's happening here is as you adjust the volume, you're actually adjusting the screen voltage here for the first 2 RF valves, and hence it'll adjust the volume that makes it to the third valve. So they also use this third valve as a detector, and they do that by keeping the cathode positive with respect to the input grid here. So that the grid here is at ground potential. The cathode here will be 5 to 10 volts higher, and what that does is it keeps this plate at almost cut off. It's so negative here that the electrons can't get through, and the plate virtually stops conducting. Now when we put our signal in, of course it has a positive and negative component, and the positive component allows this grid plate to become positive enough to let electrons flow through to the plate and conduct your signal through. The negative component makes this plate, this grid, even more negative and cuts off the electron flow completely, or almost, and you get no negative flow through. So it's virtually acting as a diode and just allowing the positive parts. The downside of this idea, and probably why it didn't last very long, is that small variations in the positive side of this don't give you enough impetus for the electrons to flow, and you end up with a distortion. So low signals through there will end up slightly distorted. There's a cap here that's I assume is to bleed off the carrier wave part of the signal. There's another RF choke, so that'll get rid of a bit more of the RF, and you should end up with just an audio signal going into your output valve. I've just been looking at this phono input. It's quite interesting. There's the phono input is sent up through straight into the grid of the valve here. The earth, there's the ground for the other terminal. There's a phono switch, radio phono switch here. When it's put to phono, it's over this side. So that breaks the ground connection for this transformer, and that isolates the RF part of the circuit, so you don't get interference from the RF into your gramophone input. Also, it connects these two together here, so that puts that 500 ohm resistor in parallel with a 20k resistor, which drops the voltage of this cathode here and alters the bias between the cathode and the grid, and this just becomes a preamp valve to feed off to the amplifying valve. Which begs the question, how does this volume control affect the input to the gramophone? This is only to do with these two valves here, as far as I can tell from this circuit. If you've got any idea how that affects the volume on the gramophone input, let me know in the comments. That'd be great. If once I get this going, if I do get it going, I'll inject a signal in here. We'll just see if that actually does affect it, and then try and work it out that way, perhaps. Before I do pull it apart, I should check a few things for continuity and just make sure everything's going to work before I even start. Here's the two secondaries coming out of here, so we can check those. I've got my meter there on ohms, and just looking at the circuit diagram there, it should be 190, I think, and 180, yeah, about 190 each, so about 340. That looks a bit low, doesn't it? That might be 198 ohms. Let's try that. Can't go through ground because there's a resistor somewhere. I think that's the resistor there, so that should be the center tap. That should be right. There's the resistor, so we should be measuring about there. What have we got there? 153. That doesn't sound good, does it? And that's 187, so that's about what it said there, 189, so I think maybe that one not working so good. What I might do, I'll take the all the valves out so the filaments aren't being heated, and we might just put some power on, just check these voltages before I go too far down the road here with this. So all the valves are out. There's I've taken them all out, so the filament's not doing anything, the filament winding's not doing anything. The secondary's just sitting here, it's not doing anything. And there's the 5 volt supply, it's just sitting there, that's not going anywhere anyway. So let's put the dim bulb on, we'll see what happens. The bulb should virtually not come on. So that would indicate there's an issue inside there somewhere. Yeah, that should, I mean, it's not pulling any power, it's not doing anything. It shouldn't be doing that. I'll just try another approach. I've turned the dim bulb up. I'm just bringing it up on the variac. It's pulling 20 watts at about 77 volts, which you would think is too much, seeing it's got no power on. Yeah, so 75 volts going in. Just see if this is actually working. It's producing 73 volts on that side, 107 on that side, so definitely something wrong with the secondary, and I think we can assume there's something wrong with the primary as well, or it may be just reflecting back into the primary, I guess. Alright, better go and hunt for a new transformer, I think. First thing I'm going to do is take the transformer out. So I've got to desolder all these wires. I've taken some photos of the circuit, and hopefully I'll be able to put it back and get it in the right place, or whatever replacement I put in. Well, there it is. I assume that little cover comes off, so give that a go. He says. I can see the core there, just there. So it's a pretty big transformer. Now, a number of ways of getting this out. Apparently, I've never done it, so this will be new. But you can freeze it, and hopefully it'll come out of the can if you whack it slightly with a bit of wood or something, a bit of timber. The other thing to do, of course, is melt it out. So if you melt it, it's going to go everywhere and stink. If you freeze it, it's going to chip everywhere. So I don't know which is the best way of doing it. One wonders if it would just come out. No. Okay, I've got my heat gun here. I'm going to try and just heat it all around gradually and just see if it slides out gently onto the ground. Well, that's been 12 and a half minutes and no sign of it moving, so I'll try something else, I think. I ended up putting it in the oven. It was on about 200 degrees C for probably 20 minutes, and it just slid out the bottom, so that's come out alright. I need to go now, and I think I'll need to get this one rewound, so I've got to find someone to do that. In the meantime, I'll move on to other things. Well, it appears that I'll have to get that old transformer rewound. I can't, nobody's got a new one, they're so old anyway. So it looks like it's going to be rewound. I just better check a few other things before I send it off. These two wires here are for this choke here, that one. And that's the RF choke, so that's that one there, so I can check both of those. I'll just change the clip leads, they're a bit easier. So that looks alright. Well, I don't know what it's supposed to be, at least it's got continuity, so that's okay. I'll just see what this RF choke is. Once again, I don't know what it's supposed to be, but with 253 ohms, it's got something in there, so that's good. There's the output transformer, so there's two thick wires there running off to the plug for the voice coil, and we're going to check these two wires here, the thinner ones that are running off the plate and come from the power supply. There's two big wires there, they're going off to the voice coil. I can check across there. There's a wire here, that's the plate of the output valve, and I assume this is the power supply coming up from the transformer, the power transformer. So I'll just we'll do these first. Okay, so we've got about 7 ohms there. I would expect something similar to that. So they come out here, we could put one there, and the other one would be here. We should get nothing. You gotta be kidding. Well, that's disappointing. There's another one. Another transformer I've got to get wound. This, I mean, an output transformer normally wouldn't worry me, but the gauge of this wire is like fencing wire. It's very thick. So I don't think any modern transformer is going to do the job there. I'll have to look around for that one. I think these transformers are housed in that second big can that's in the sitting on top of the set. So I should be able to put a meter on here and here and measure that choke, and I can put a meter from here to here probably, and I can measure that choke, see if we've got continuity there. So I've connected that. That's the AC, rectified AC point there going into there, and this is it going into the bottom of the output transformer. So if I put it there, we should be checking. We got something? Yeah, so I've connected to there and about there. So that's got something there. Once again, I don't know what it's supposed to be. So in order to check that choke there, I can connect there. About the closest I can find is here. I know where that is. So there's 30k resistor in there, but it's not going to make any difference because I don't know if it's I don't know the measurements of that anyway. So I'm just making sure it's got continuity. Okay, that's one point, and the other one should be just before it goes into the choke on the way to the plate. And it's reading 5 meg. 5 meg's too high. I suspect that indicates the choke's open. When I pull out the choke pack, I'll check it again. I also buzzed out these 3 transformers, and also the speaker, voice coil and field coil. They're both fine. So apart from the power transformer and the output transformer, I have made arrangements to have them repaired. So that'll take a little while to do. So I've got other things I'll do in the meantime. While I'm waiting for my new transformer, I thought I'd have a look at this can here and just take it off and just see the capacitors in there, and there's 2 chokes in there, I think. Now, I've looked on the internet, there were some photos there that seemed to indicate that you could just take the top cover off, undo the screws, and just pull the cover off, and everything would sit there. So I'm going to try that today. I've flipped the chassis over, just removing the 4 bolts that hold it on the bottom there, and flip it back, and we should be able to lift it off. Now, the whole thing's loose, but the base seems to be staying there, and it's looking good so far. There's a little shim there. There's been one of those in each of the cans. I'm not sure what they do. And there they are. There's the capacitors on the left, and the choke transformers are on the right there. A little bit of wax leaking out of all those. These are the capacitors I've bought, and to replace the ones in there, they're only 3 and 1, the 4 capacitors. Apparently that's their value, and these are 1 microfarad capacitors. So I'll put those in there. I've got some 4.7 as well, which I'll use for the 3s. I want to remove the 2 chokes that are in here, and just to test them, I've got to get them out anyway. So I've just come up with a numbering system. So I've called this block A, and I've got A1, 2, 3. So I'll just number these. I don't have to take all of them off. There's only about 4, but I'll just number them anyway. So we'll start doing that, and then I'll take the solder off. There it is. It's got 4 wires coming out of the top, and that adds up. There's 1, 2, 3, 4 wires, so we should be able to measure those. This is B2, so this is the one coming in from the power supply, so we should be able to measure that and the second choke by itself. So we've got 183 ohms on that one. That's 180 odd, so this should be 360, 370 odd. And there it is. So there's our power going in, and the first tap, that's 180 odd, and the second tap going through the lots 370. So they're all intact. So that end one there, and if I measure between there and there, I have no idea what it'll be, but it should have continuity. If that's power going in, that'll be the center tap, and that'll be the full choke, the first choke. So we should go from the first choke there, that should be connected to this choke here. So we should get a continuity between those two. And there's nothing. Can you believe it? Nothing. It's open. Unless I'm misreading it, it's got to be it. That has to be it. There's nothing there. It's open. Alright, that may not be a big deal. We can probably put a resistor in instead of that. This thing's fighting all the way. So I thought I might just take this capacitor pack that's in here out, that sits up the top. The wires are coming through here and they're soldered mainly onto this resistor board here. After I've done that, I might just flip it over and see how the top of the chassis responds to some treatment to see how it's going to come up. But I think to restore this back to its original, I'm going to probably need to strip all this out and get it plated again. That's what I'm thinking at the moment. It doesn't look too bad. I've got to remove all these plates, the valve plates. Most of it will come off as a unit, and I can just lift it away and hopefully just lay it back in, and everything should line up again. These items here, obviously I can't do that, so I'm going to number them and pull that, unsolder them. Well, that's that removed. I'm tempted to melt this wax out and even keep the wax because it's handy for other things. And just see where all these wires go to. I do have a circuit diagram now that does give you some clues with the color coding, but you've got 3 blues going in there. I can't imagine, and a black, that's ground. And these are just all yellow, so I don't know. I need to find out where they go, I suppose. It doesn't really matter. I suppose I can just wire it as it needs to be off the circuit diagram. Now this chassis, as I said, it's got quite a bit of rust on it, so I don't know how we're going to combat that. I'm thinking of getting it replated. But I watch Mr. Carlson's labs, and he said to use Vim, which I don't know if we even have it in Australia anymore, but it's a powdered cleaner. But they do have a product called Gumption, which is a multi-purpose cleaner. They don't sponsor me at all. The product's pretty good actually. But anyway, he uses Vim and tries to rub the rust off with that, mixed with some water. His chassis came up pretty good, and I expect this one will just shine like... No, I don't think it'll do anything actually. I think it's just moving the rust from one place to another. Yeah, I expect that's about as good as it's going to get. I can keep rubbing at it. There's a whole chassis to do it. I don't know how long you want to spend doing this sort of thing. I suspect it's not going to get much better than that. Yeah, that's got a nice thick coating of rust on it, so it's not going to come off. I'm going to pull it apart, take it down the platers. They're going to put zinc on it, so it's going to come out a bit shinier than it should. I don't know what I can do with that, whether I can coat it with something. I don't know. Have to see how it comes out. While we're here, I might give this top of this RF transformer a bit of a rub, see what that does. It's not doing a bad job actually once you get into it. It's still got the rust on it though. So I'm going to have to use a light wet and dry and some water and just maybe spin it and clean it or something. I'll work something out. That's actually not coming up too bad. So I thought I might have a look under this cover here. There's some capacitors in there. Okay, let's see what's inside. Just three capacitors. I assumed there'd be some sort of trimmer on it. Actually, look at that. There's one there. Yeah, look, you pull a plate closer to those capacitors, the plates on the outside of the capacitor, and there's the hole. So yeah, put a socket through there. I thought there would be something like that. That's going to be something else, is to align these. I don't really know how to do it at this stage, but I assume you mechanically align it and then trim the top end. Yeah, I don't know. We'll have to find out. Now, there's some screws in there, and they hold on a little cover, and I believe there's the capacitors in there. Can't quite Can't quite get to the bottom of them. They're under some wiring, but I might be able to just loosen these off. There's the can that I believe's got a capacitor in it. I'm not sure what else is in there. I did undo the two nuts. There's two screws from the bottom there, so I'll just try and finish them off here. Well, there it is. It's all packed in something. Wax. Yeah, wax. There. Alright. Well, they were keen on wax, weren't they? So that doesn't help me. I don't know what's in there. I'll have to look at the circuit diagram and try and work it out. I believe they're small value capacitors. These are old radios. It's such a different way of doing everything, so it makes everything hard for someone like me, a novice like me. So I'm struggling with this, I've got to say. So from here on in, I'm just going to strip all this out, get rid of all this stuff, and try and make sure I can put it back together again, of course. So it'll look good when it's done. Now whether it'll work or not, might be just a static display in the end.